Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. In the lecture series of Material Studio, we are at the lecture number 27, and in today's lecture we are going to compare two popular density function theory codes, CASTEP and ONETEP, by examining their calculated density of state for a specific molecular and metallic system. Let's start with the graph A. Here we see s orbital contribution to the DOS of the ethylene molecule C2H4, while the red line represent the result from CASTEP, and black line show the ONETEP results. Remember, the x-axis is the energy in the electron volt, and y-axis is the DOS in arbitrary unit. We are primarily interested in the shape and relative heights of the peaks, as the absolute value are less important here. So notice that both CASTEP and ONETEP show peaks at similar energy positions. So this indicates that both programs agree on the energy level of the s orbital and ethylene. However, you will observe a slight difference in the peak height. This variation can arise from the different basis set and numerical approach used by each code. Essentially, they are both capturing the same trend, just with a slight difference. So now let's move to graph B, which display the p orbital contribution to the DOS of C2H4. Again, we see a similar story. The peak position are consistent between CASTEP and ONETEP, showing good qualitative agreement. So, and the peak heights is before show the same minor variation as we saw in the s orbital example. So this consistency reinforces that both methods are accurately representing the electronic structure of the molecule, just with the minor difference. Finally, let's look at graph C. So this shows the d orbital contribution to the DOS for 1-1-1 direction. This is more complex system, and we see a more interacts DOS. Notice the border peak, especially specifically around 0 electron volt. So this is typically for d orbital and transition metal like platinum, indicating delocalized electron state. While the peak position are still in good agreement, you will observe a more noticeable difference in the peak shape and intensity. This can be attributed to a several factor. As ONETEP use localized function, while CASTEP use plane waves. This difference in basis set, along with the choice of pseudo potential in CASTEP and how each program treats core electron, can lead to variation in d orbital representation. Finally, is both the CASTEP and ONETEP provide qualitatively similar results for the DOS, indicating that they agree on the fundamental electronic structure of the system we have examined. So the difference was observed are mainly due to the inherent difference in their methodology, such as basis set and numerical approximation. So the level of agreement can vary depending on the complexity of the system and the type of orbitals being considered. However, the overall message is that both programs are producing very similar reliable results. With this, thank you very much. If anyone have any question regarding CASTEP versus ONETEP, so please feel free to comment.